Today's lesson is about an important mathematical concept known as sets. The first important question would be, what is a set? A set actually is a collection of objects. A set could be about anything. For example, I'm going to draw a visual representation of a set that represents 3 of my favorite colors. For example, this is the set. I'm going to represent it as a circle, and I'm going to write black, white, and blue. So this is a visual representation of the set of my favorite colors. Now the question is this visual representation mathematically acceptable? Of course not. This is not the proper mathematical language that is used to represent a set. Then how do we represent a set mathematically appropriate? To represent a set mathematically correct, you have first of all to give the set a name. The name of a set could be any letter, A, B, C, D, any letter, as long as you write it in uppercase. I'm gonna name my set A. Uppercase A to name the set. Equal. When I write equal, that means the set A contains the following. The following what? The following elements or objects, but the proper mathematical language is to use elements. What are the elements of my set? The elements of my set are black, white, and blue. So I need to write them next to my set. Someone will come and ask me, is order important? Of course, order is not important. I can start with blue or white or black or the opposite. So I can write black, blue, white. Those are the elements of my set, the objects that are found in my set. Is this the proper mathematical representation of a set? Wrong. There's something missing and it's very important. They are curly brackets, not any type of brackets. Only those brackets represent a set. I start with brackets and I end with it. So black, blue, and white are the elements of set A, and we agree that always a set is named by an uppercase letter. Is this the only way to describe a set, by listing the elements? This is one way. Listing the elements of a set is one way. I can also write my set in words. I can describe it in words. For example, A is the set of what? Of my 3 favorite colors. And I close the curly brackets. As you can see, I wrote the name of my set, which is A equals. I wrote the 2 brackets and I described my set in words. My 3 favorite colors. Now, you would ask me, how would I know how to describe the set? It depends on the question. The question might ask you to describe it in words or by listing all the elements. Usually, we list all the elements because this way helps us more in identifying other concepts in sets. One of the questions that could be asked related to sets, what is the cardinality of set A? First, let's explain what does the word cardinality mean. Cardinality means how many elements are there in set A. As you can see here, we have 1, 2, 3 elements in set A. Now, how do we represent that mathematically? To represent the cardinality of set A, we write lowercase n, parentheses A is equal to 3. This can be read as there are 3 elements in set A, or the cardinality of A is 3. Another question would be asked, is blue an element of set A? As you can see here, is blue an element of set A? Yes, I can find the color blue in set A. So the answer would be yes, but now I'm going to teach you how to answer it mathematically. Yes, blue is an element of set A, but mathematically we say blue belongs to set A. I don't write the word belongs. I have to represent it mathematically. I use the following symbol. This symbol here means belongs. So now if I read it, blue belongs to set A using the appropriate mathematical symbol. Another question, is green an element of set A? As you see here, if you look into the elements of set A, you do not see green. So no, the answer is no. Green is not an element of set A, but I don't write the word not an element, or I don't write does not belong. So green does not belong to set A. Instead, we use the proper mathematical symbol, and that's the symbol of belong with a dash on it. So I read it, green does not belong to set A. As a summary, a set is given an uppercase letter as a name with the equal, the curly brackets, and as much as elements are present between each element there is a comma. Order is not important. Another point is cardinality. Cardinality is how many elements are present in a set, and it is written as n, 2 parentheses, and the set A. Another point, belong, and this is the symbol of belong in case the element that is given is in the set, it's part of the set. We write the element belongs to the set, or does not belong. This means when the element that is given is not part of our set. Example 1, B is the vowels in the English alphabet. Question number 1 says, find the cardinality of set B. As we explained before, a set can be described in words, as given in example 1, or in listing its elements. Here, find the cardinality of set B. Describing it in words will not help us. For this reason, we're gonna transform the description of a set in words into listing all the elements, which we can do because we know the vowels in English alphabet. So I can write B equals with the 2 curly brackets, and the alphabets are A, E, I, O, and U. Now, once we listed the elements, I can now identify the cardinality of set B. Remember, cardinality means how many elements are present in this set. We represent it as lowercase n, number of elements in set B. We don't forget the 2 parentheses, equals. We will count them, simply count them, 1, 2, 3, 4, 5. So the cardinality is 5. We move to the second question. The second question, identify if each statement below is true or false. We're going to read the statements and then write T for true or F for false. We'll start with the first statement. A, which is letter A, belongs. Remember, the symbol represents belongs to set B. A belongs to set B. This means A is part of set B. We look back at the set. Is A part of the set? Yes. And that's a true statement. So true. The second statement. C belongs to set B. We look at the elements. Is there any letter set? No. So C is not part of set B, does not belong. Then this statement is false. Statement 3. D does not belong to set B. This means D is not part of B. This means I'm not going to find D in this set. And that's true. D is not found in the set. Then this is a true statement. Statement number 4. I does not belong to B. This means the statement says that I should not be in set B. But this is wrong because I is in set B. So this is a false statement. The fifth statement, B cannot be written as A, I, O, E, U. If you look over here, the elements are the same in this one and this one. The order is the only thing that is different, but we mentioned before that order does not matter in a set. I can write it in any order. So this is wrong because I can write set B as A, I, O, E, U because all the elements are found. So this is a false statement. Another question, we are given two sets and we need to tell whether the statements are true or false. The first statement is 4 belongs to set A. So 4 should be found in set A. Let's test that. Is 4 in set A? Yes, it's true. 4 is in set A, so this statement is true. The second statement, 1 belongs to B. So 1 should be in set B. Let's test it. Can you find 1 in set B? No. So this statement is false. The third statement, 7 does not belong to set A. So based on the statement, 7 should not be in A. Let's see. No, unfortunately, 7 is in A. So this statement here is false. Let's continue. 3 does not belong to B. So the statement says that 3 should not be in B. So I'm not supposed to find the 3 in B. Let's see. Can you find the 3 in B? No. So this statement is true. Statement number 5 says the cardinality of A is 3. This means that there are only 3 elements in A. Let's count them. 1, 2, 3, 4. No. The cardinality of A is 4, so this is a false statement. Statement number 6, the cardinality of A is equal to the cardinality of B, so they have equal number of elements. Let's test it. The cardinality of A is 4. Let's see the cardinality of B. B has 1, 2, 3, 4 elements. So in A I have 4 elements and in B I have 4 elements, so this statement is true. Let's take the following set. Set A has the elements 1, 2, 5, and 8. The cardinality of set A is 4 because it has 4 elements. Now we call set A because it has a limited number of elements, a specific number of elements, and a specific cardinality, a finite set. Let's take another example. You know from grade 8 that we have some common number sets, the set of natural numbers, integers, rational numbers, and so on. Let's take the set of integers. And you know that integers, they are the non-decimal numbers that are positive and negative, and it's symbolized by Z. So it is the set of negative and positive numbers that are non-decimals. So I have many numbers in the negative side. I'm gonna list a few. Now because we do not know where to start from and we have many numbers in the negative sign, we write 3 dots. The 3 dots means that the pattern continues. There are other numbers than the one I started with. Only 3 dots you write. Then I'm gonna start, for example, from -3, then -2, then -1. I'm gonna continue 0. Also positive numbers that are non-decimals, for example 1, 2, 3, then I'm gonna write 3 dots only. This means that the pattern continues. As you can see here, I do not have a specific number of elements. So I do not know the cardinality of the set of integers. For this reason, we say that the set of integers is an infinite set. An infinite set means I do not have a specific number of elements. So sets could be finite, they have a specific number of elements and we know its cardinality, and infinite, it does not have a specific number of elements. Other examples of infinite sets could be the set of natural numbers, the set of real numbers, as we said, integers and irrational numbers. All those are infinite sets with infinite number of elements.